In this demo, we will add a cache store. Let's switch to the Configure Services method in our Startup Helper Extensions class. What we want to add here is a call into builder.services.add-response caching that registers the necessary services on the container. And then we need to add the response caching middleware to the request pipeline. We do that in the Configure Pipeline method. Make sure it is added before the call into map controllers, which enables endpoint mapping. We want to ensure that the cache middleware can serve something up before the rest of the MVC logic is routed to or executed. Let's give that a try. Let's send our request to get a course. We hit our breakpoint. So far, so good. We get it back with a cache control response header. Max age is 120. Let's send this request again. This time, we don't hit our breakpoint. Our response is served up from the cache. If we look at the response headers, we notice a new header, an age header. This states the age the response has been in the cache, in seconds. Let's send this request again. The age changes. Now let's wait a bit until 120 seconds have passed. Let's send the request again. And there we go, we hit the breakpoint again. That makes sense because the cached response went stale. So far, so good. Now, you might have seen the cache control directive being used for a request instead of a response. And that is a valid use case. Both clients, through requests, and servers, through responses, can partially control caching rules. We will look into these later on in this module. But first, let's cover something else. Often, the caching rules for different resources are the same. 120 seconds for a course, but also for a set of courses, or an author, for example. Cache profiles can help with that. Let's continue with the next demo. In this demo, we will learn how to use cache profiles so we can easily apply the same rules to different resources. We're again looking at our Configure Services method. When adding controller-related services to the container, we can configure cache profiles. To add a new one, we call add on the cache profiles dictionary on the options of add controller. We give it a key, say 240 seconds, cache profile. We should give it a value of type cache profile, and on that we can find different things we can configure. These will all be looked into. Let's set the duration to 240 seconds. Alright, so far for that. On to the courses controller. Cache profiles can be applied through the response cache attribute. And we can do that at controller or action level. Let's say we want to apply our new policy at controller level. We do that by setting the cache profile name property of the response cache attribute to the name we gave our cache profile. Let's give this a try. Let's start by sending a request to get an author's courses. Let's have a look at the headers. And we see a cache control header with a maximum age of 240 seconds, just as we configured through our new cache profile. Now let's send our old request again. We again hit that breakpoint that has still been applied. We see that for this resource, the cache control header contains a maximum age of 120 seconds. And that makes sense, because we apply the response cache attribute at action level for this route. From that, we know that the response cache attribute, when applied at action level, overrides the one applied at controller level. So that's pretty cool, right? But how does all of this actually work? In other words, what are the mechanisms that decide on whether something is served up from the cache store or not? Let's have a look at the expiration and validation models. The expiration model is a way for the server to say how long a requested resource, so the response message, is considered fresh. A cache can then store this response, so subsequent requests are served from the cache as long as it is still fresh. For this, two response headers are used. The expires header is the simplest one. It contains an HTTP date stating at what time the response expires. But that is a potential issue. The clocks between the cache and the server have to be synchronized. It also offers little control over what type of response can be cached when and where. It's been superseded by the cache control header, which addresses these limitations. In the example on the slide, you see a cache control header value, public max age equals 60. This response header contains two directives, max age and public. As we learned during the demo, max age states that the response can be cached for 60 seconds. This also means that clock synchronization is no longer an issue. To recapitulate, public states that it can be cached by both shared and private caches. So the server can decide on whether or not a response is even allowed to be cached by a gateway or proxy cache. Those are shared. Or whether it's allowed to be cached at all, for that matter. There's quite a few possible directives next to public and max age. You can find those via the link on screen. They're divided between directives that can be sent in a request, which means the client can decide on some expiration-related values, and directives that can be sent in a response, which means the server can decide. We will look into these later on, as some have to do with expiration and others with validation. So we have to cover that first. Let's have a look at how this expiration model works. Imagine we have a client application, that's the consumer of our API, a cache, which can be shared or private, and our API, the backend. The application sends a request to get the authors. The request hits the cache. There is no cached version of the response available, so the cache forwards the request to our API. Our API should then return a response, including a cache control header that, in case of our example, states that the response will stay fresh for 1800 seconds, or half an hour. That hits the cache again, and the cache then forwards it to the consuming application, but at the same time, it stores a copy of this response. 10 minutes later, our application sends a GET request to the author's resource again. We hit the cache, and this time that cache has a response that hasn't expired yet. It sends back that response, including an age header. In our case, that age is 10 minutes or 600 seconds. A request to the backend is thus eliminated. Only when the cached version reaches the expiration time, which means it becomes stale, the cache will hit the backend again. If this cache is a private cache, like one that lives in local storage for an Angular app, or one that lives on a mobile device for a mobile app, this is where it stops. But if we assume that this cache is a shared cache, living on the server, for example, it's a bit different. Imagine that 10 minutes later, a subsequent request from another instance of the client application, or another client application that consumes the API, to API/authors is sent. It will hit the cache, and assuming the response hasn't expired, it will serve that up from the cache, this time with an age header of 20 minutes or 1200 seconds. So there's again no communication with our API. If it's a private cache, subsequent requests save bandwidth and they reduce requests to the API. As long as the response hasn't expired, we don't hit the server anymore for requests coming from the same client instance. But of course, when different clients send the same request, they still hit our backend, as they all have their own private cache. If it's a shared cache, subsequent requests don't save bandwidth between client and cache, but it does drastically eliminate requests to the API. Imagine there's 1,000 simultaneous consumers of our API. The first one hits the API, all the other ones hit the cache, which also means that a lot less code has to be executed. The number of times the database has to be accessed goes down drastically, and so on. This is a pretty good reason to combine a client cache and a shared cache. The exploitation model is nicely supported by what we've used up until now: the response cache attribute and the response caching middleware. But looking at exploitation like this is typically only good for content that is quite static: images, web pages, mastered data, and so on. So it's actually not that good of a fit for APIs like ours, of which the data can dynamically and often change. If an author is added by one of our 1,000 consuming applications, the author's response that's cached isn't correct anymore. In the worst case scenario, with an expiration of 30 minutes, we end up with as good as 30 minutes of invalid data. That is what the validation model takes care of. Let's have a look.